All right, section 1.8 and 10.1 we combined together, guys. It's talking about area and perimeter. Up here at the top, you see our area of a triangle, area of a parallelogram, area of a rectangle, and area of a circle formulas. You need to know the area for all of them. This perimeter of a rectangle we'll very rarely use because we know the perimeter of a rectangle, we just add up all of our sides. We will use both of our circumference formulas for a circle. All right. Question 1 asks us to find the perimeter of the path and the garden together. So essentially they want us to find the perimeter around the outside of this entire thing. All right. So if I'm going to do that, I first need to figure out what each piece is. So I know on the inside, we know that this is 22. Then we know that we have 4 here. And then that also means we would have 4 here because it's even all the way around. If we add all of that together, we would end up getting 30. We need to do the same thing for the top. We know that we have 16 here. So we add a 4 to it and a 4 to it, and we get 24. Now that we know both of those dimensions, we can go ahead and solve for the perimeter. The perimeter is just adding up all the sides. So we get 30 plus 24 plus 30 plus 24, and it gives us a total of 108 inches. Remember, perimeter is always measured in just the units that they give us. So we would just leave it as so. All right, to find the area of the path and the garden together, we need to use the area formula. Area of a rectangle says we're going to take base times height or length times width, either way you want to say it. So we're going to take 24 and multiply it by 30. If we do that, we get 720 inches squared. Area is always measured in units squared, so whatever we get, we just put inches squared with it. All right. For our next question here, they want us to find the area of the path only. So if I'm looking at that, I can kind of get rid of all of this stuff. We're going to keep the area of the entire thing because we're going to need that. But we want to find the area of all of this. So that means we need to use the area of the whole thing minus the area of just the garden. So now we know that 720 is the area of the entire thing. So now we need to find the area of the garden so that we can subtract it. The area of the garden, we're going to take the 22 that was there and multiply it by the 16 for the base and the height of that, and we get 352. So we know the entire thing is 720. 352 is what we need to get rid of, so we subtract them. So we take the 720 minus 352, and we're going to end up with 368 inches squared for the area of just the pathway. All right. Moving on to our circle formulas here. It says find the circumference and area of the following circles. It says to round to the nearest tenth, but I'm also going to talk about what it says in terms of pi here. Let's start with circumference of number 1. The circumference formula we're going to use, since it has a diameter, we're going to use the diameter formula, which is pi times diameter, which is 13. So guys, if I'm talking about leaving it in terms of pi, your answer would be 13 pi meters. We would actually just stop right there. That's what it means in terms of pi. We kind of treat pi as if it's a variable, okay? But this one did say to round to the nearest tenth. So if I take 13 and multiply it by pi, I would get 40.8 meters when I round to the nearest tenth. We also can do the same thing with area. Area equals pi radius squared. Well, the problem is right now we've got a diameter. Diameter is all the way across, the radius is halfway across, so we need to go ahead and cut that in half. If we cut that in half, we would get 6.5 squared, all right? So we can go ahead and do the 6.5 squared, and we would get 42.25 pi meters squared. That's if you wanted to leave it in terms of pi, but again, this one says just to round to the nearest tenth. So we're going to go ahead and round that to the nearest tenth by saying what's 42.25 times pi, and we would get 132.7 meters squared. All right. For number 2, we're going to do the same thing here. We're going to do circumference first equals. For this one, they've given us a radius, so I'm going to use the formula 2 pi r, so 2 pi 6. That can actually simplify to 12 pi, right? So we got 12 pi inches. The problem is they also want us to do this to the nearest tenth, so we go ahead and put 12 pi into our calculator. and we get 37.7 inches. Can do the same work here with area. When we do that, we're going to do pi radius squared, so pi 6 squared. Well, 6 squared is 36, so we're at 36 pi inches squared. Again, we don't want to just use in terms of pi. They want us to round to the nearest tenth. So we're going to take 36 and multiply it by pi, and we're going to get 113.1 inches squared. All right? Now, on our next problem, they want us to find the perimeter and area of an irregular figure. So what we need to do, guys, you need to think about this. If we're going to find the fence, we need to know every piece, right? So we know this piece is 20. We know this piece is 18. We know this piece is 5. We know this piece is 10. And we know this piece is 18. You can ignore the 5 for a moment, but we still need it. Now, we need to figure out what this piece right here is. If I want to find that piece, it's going to be the same as this. So if that's 5, this is also going to be 5. Which means this piece right here is also 5. The last piece we got to find is this one here at the bottom. Be careful on this. A lot of people automatically assume it's 5 because of what's over here. You cannot do that. What you got to do is say, all right, well, we know the whole piece up top is 20. We know this part of it is 10, right? So we take 20 minus 10. That gives us 10. Then we have 5 right here, so we take 10 minus 5, and we learn that this is still 5. Now, you can't automatically assume that, and make sure that you do the work for it to make sure. So if you want to find the perimeter, we're just going to add up all the pieces. So we're going to take the 20 that's on the top. Then we're going to take this 18 over here. Like I said, we're going to ignore that 5 at the moment because the 18 is the entire length. Then we're going to take the bottom 5 right here. Then we're going to take the 5 right beside that. Then we're going to take the 10. Then we're going to take another 5, which is right here. Then we're going to take the 5 below that. Then we're going to take the 18, and we're going to add all of that together. Once you put all that in your calculator, you should get that the perimeter equals 86 units. Now, we're writing units because we don't know what measurement they're giving us. It could be inches, could be feet. Whenever they don't tell us, we just put units, all right? In perimeter, like we said, we don't use units squared, we just use units. Now, the next question is asking us to find the area of it. So we need to remember a lot of those measurements, but the main thing is we've actually got to split this into different shapes. That's what's going to make it easier. One of the easiest ones to do is to split it just like this. Then you can find the area of this top piece very easily. Then you can find the area of each one of these small blocks right here. That's the way that I would do it. It makes it a little bit easier. So let's find the area of the blue piece first. We know that the base of it is 20. We need to figure out what the height is. A lot of people accidentally put 18. Problem is 18 is the whole length, and we know this piece down here is 5. So we subtract those, and we would actually get 13. All right? So once we do that, we do 20 times 13, and we get a total of 260. So that's for the top piece. This piece is 260. Now we need to figure out each one of these small pieces here. So we know from what we did earlier that it's 5 and 5 here, and it's 5 and 5 here. So we're just going to take 5, multiply it by 5 for the first one, and we get 25. Take 5 and multiply it by 5 for the second one, and we also get 25. So now to find the area of the entire figure, we just go ahead and add all of that together. So we're going to take the 260 plus 25 plus 25, add all that together, and you end up with 410 units squared for the area. All right? So make sure that you, and it really doesn't matter how you split it up, you kind of get to choose on that. All right? On the back, we need to find the area of a parallelogram. Area of a parallelogram equals base times height. Well, the base and the height will always meet at a 90-degree angle. So this bottom piece right here is going to end up being my base. Well, in a parallelogram, we know if the top's 18, the bottom's 18. So we know for a fact in our area that our base is 18. The problem is we don't know what the height is right now. So we're going to put an X right there, and you notice we have an angle, a number there and an X there, and a right triangle. So we're actually going to use SOHCAHTOA to solve for it. We have an opposite and hypotenuse, so we're going to use the sine of 60 equals opposite, which is X, over hypotenuse is 12. When X is up high, you multiply. So we're going to take 12 and multiply it by the sine of 60. When you take 12 and multiply it by the sine of 60, you would get 10.4. So we now know that 10.4 is our height. All right. So we go ahead and multiply those into our calculator, and we get 187 units squared. And it is squared because we are talking about area of this parallelogram. All right. We're going to use the same thing for number 5. The things that you got to know is which ones are your base and your height. Well, here's where your 90-degree angle is going to be made, right? So your base is actually going to be the 12. So we can start by saying area equals 12 times, and then we got to figure out what our height is. We can also think about it this way. We could put our 60 over here because we know those angles are congruent in a parallelogram, and we can also move our 10 over here because we know opposite sides are congruent as well. So if we put x here, we're going to use sine again because we have an opposite and hypotenuse. So we're at the sine of 60 equals x over 10. Again, x is up high, so we multiply. So we take 10 and multiply it by the sine of 60. When we do that, we get 8.7 when we round to the nearest tenth. So that's what's going to go in for part of our area. When we multiply those two things, we get 104.4 units squared. You don't have to write out units every single time. You can just do U. We know what that means. All right. Next up, we need to find the area of a square. You could do this one of two ways. I'm going to show you both ways. If I'm going to use the formula for area of a square, which you'll see on a formula sheet, we don't really put it on there. It's just take a side and square it. Because a square, we know all four sides are the same. So we would just take the 5.4 and square it. Well, if we do that, we would get what? We would get 29.16 centimeters squared. All right? Now, the other way to do it is to treat it like a rectangle because we know a square is a rectangle, right? Or a parallelogram. So we would just take the base, which is 5.4. We would take the height, which is also 5.4 because both of these sides are going to be the same, and then multiply them, and you would still end up getting 29.16 centimeters squared. Either way works. Most people forget the area of a square formula, so we just use the area of a rectangle formula. Last but not least, we have the area of a triangle. This is the one that is actually most forgot about because they forget this part right here, which is the 1/2 of the base times the height. Do not forget the 1/2 part of this, all right? So the base and the height will always meet at a 90-degree angle, so the base is this bottom piece, so 7.3. The height will be the line that meets it at a 90-degree angle, so 3.4. Once you've done that, you can go ahead and put that in your calculator, and you get 12.41 centimeters squared. All right, those are your notes for 1.8 and 10.1. Make sure that you come into class with those completed.